Good morning. People have joined 1, 2, 3, 4. Somebody has joined twice. Mehak, you have joined twice. Yeah. Let's see some of the people. I was just waiting for everybody to join in. Okay, that's fine. Yes, so we can start. More or less everybody has joined, except 1 or 2 people who may be joining a little bit late. Some network issues maybe. Yeah. Are there any people who have been in my previous workshops? Who is repeating there? Yes, please, Marie Jacob. You have joined or not joined?
Sir, I joined, but the profile is using my husband's because I'm not able to log in using my mail ID.
Okay, no problem, no problem, no problem, no problem. Yeah. And there are some people who have been in my previous workshops. Like I know Somitro and 1 or 2 people are still there. Let us start without wasting time because we have a lot of things to cover in today's workshop. Yeah. So the topic that we'll be covering is the factor analysis, CFA and CFA. So let us go to EFA first. Before that, we have 3 grouping techniques. Yeah. There are 3 grouping techniques or multivariate analysis technique which is generally used. One is factor analysis, another is discriminant analysis, another is cluster analysis. My previous 2 workshops, which had happened 2 weeks before, were on cluster and discriminant. So, can anybody tell me that what is the difference between the grouping of these 3 techniques? Factor, cluster, and discriminant. All are grouping techniques in some sort of way. Yes, Somitro, you have joined? Soumitra. Okay, your audio is not working. So anybody else? You must have heard of these three techniques. No? So what is the difference? Can anybody try to tell? Factor, cluster, and discriminant. All are grouping techniques only.
Sir, I don't know if I'm right or wrong, but I'm just trying.
Yeah.
So factor analysis is used to like make factors. We have some sort of statements like maybe 10, 15, and then we try to find key that 5 statements or maybe 3 statements relate to a particular factor.
Yes.
And
Grouping the
discriminant and
statements are variables, basically, what you are saying. Correct.
And discriminant and cluster analysis is more of when we want to like club the groups, like the respondents. Maybe the customers are loyal
exactly.
and not loyal.
Exactly.
Yeah.
So when you are clubbing the groups in the respondents into groups, discriminant and cluster is used, while clubbing or grouping the variables is factor analysis. So in case of cluster analysis, you group the respondents. In case of discriminant, also you group the respondents. The difference between the two is, in case of discriminant, you start with the grouping already made. A priori grouping is done. Cluster analysis, the end result is grouping, but both cases you are grouping respondents, while factor analysis you are grouping variables. So it is also all of multivariate statistical techniques. Factor is also a multivariate statistical technique, but it is one technique which is not talking of any dependent, independent type of variables. So there are no dependent, independent variable as in done in regression or even in discriminant. We have dependent, independent variables. It is not there in factor. So basically, when you have a large number of variables and it is very difficult for you to manage such large number of variables, you try to do something called as factor analysis. That's exactly what you do. So, is this not working? Yes. So basically what you do is you reduce the large number of variables into less number of variables, which are known as factors or groups. These factors which you make are statistically independent of each other. That's what you do. Now, what are the uses? It can be used, the main use or major use of factor analysis is building scale construction. One of the most famous example of factor analysis is the famous service quality scale by Parasuraman, Zaithamal and Berry called SERVQUAL, and later on eSERVQUAL and several other scales. So scale construction is one of the most major use of factor analysis, and it can be used, as we said, it is reducing the variables into large number of variables into smaller number of variables, and this it can be divided or it can be used as an independent variable for other methods. It is used also in segmentation, and there are several other methods or applications of factor analysis, which are new product development, product acceptance research, etc., and all those. Yeah. So one of the major use or a very simple example of factor analysis. This is what we meant. So if you are trying to find out what are the different dimensions on which you are judging the quality of a restaurant, you have these variables like waiting time, cleanliness, friendly employees, and you have taste, temperature, and freshness of food. So you use them as your, you group them into two groups of factors. One is service quality, which is talking about the service, and another is quality of food or food quality. A very simple example of factor analysis. Now it has two parts. The factor analysis has two parts. One is reducing the large number of variables into smaller number of variables or groups or factors. That is the first part, which is known as data summarization. But there is another one or second part which is called as data reduction. Now, what is that? Once you make the factors, the original variables from which you have made the factors do not exist anymore. The factors that you make are the new variables that you are having. So when you are doing that, you need to represent them with some numbers, because original variables are also some numbers. Now, when you are doing that, to represent that factors with some numbers, we use the data reduction techniques, which has two methods or two ways. One is factor score method, one is the summated scale method. Now, we will show you how it is done or where it is done once we run the factor analysis, factor score and summated scale. Yeah. Now, there are certain conditions. First of all, it requires metric data. And now you are saying you reduce the large number of variables into smaller number of variables or factors. Fine. But how do you get those variables? Literature review, interviews, qualitative techniques, FGDs, give these interviews, etc. All these previous studies, literature review, of course, we said. And all those are sources of your variables, because to make the factors, you first need the variables. If you don't have the variables, what will you group? So that is what is very important part. And another very important part, ideal sample size. Whenever you are talking of an ideal sample size for exploratory factor analysis or EFA, we talk of 10 times the number of variables. So if you have 10 questions in your questionnaire, all in Likert scale, which is a metric data basically, you need 100 as a sample size. So number ideal is that. Ideally, we need that. But we have seen that at least 5 times is not there, it will not run properly. And to be safe side, around, if you are not possible or if it is not possible for you to get 10 times the set, you may think of getting around 8 times, 7 to 8 times the number of variables. That can be an ideal sample size for the variables. So what is being done in factor analysis? The first thing which is being done is how these groups are made basically. So let's say you have the example that we talked about, the previous example, the slide that we showed, this one. Now, how is these groups made? Basically, what happens is this tries to calculate the correlation among the variables. So when you try to correlate the correlation, the variables which are highly correlated among each other will group under one factor or group, and the variables which are highly correlated among each other will have another factor or group. So that's the logic of the factor analysis. And based on that logic also, the hypothesis is prepared or hypothesis is tested, which is correlation matrix is insignificant. That means it is the identity matrix where all the diagonal elements are 1 and off diagonal elements are 0. That means none of the variables are correlated with each other. While the alternatives, it is significant. That means some of the variables are correlated among themselves, and that's why factors or groups can be made. Now, there are certain other methods. KMO is one of them. It is a measure of sampling adequacy that we use. And we'll show all of these things once we run the analysis. This is just a small introduction. We'll not waste time much on this. We'll go in another 2 minutes. We'll go into directly running the analysis and explaining the parts. Now, what are the applications? It can be used in other multivariate techniques. In multivariate regression, you can use it in discriminant, you can use in cluster, you can use in perceptual maps, and several others. All the other multivariate techniques can have or use the factor analysis as an input point, because what happens is that when you large number of variables you have, it's very difficult for you to manage. And that's why what you do a factor analysis, reduce it to less manageable number of variables, and then use them in the other multivariate techniques like regression, etc. and all those. Now coming to now from here, we'll directly go into that, your data file and analysis. So the data file that I have sent this data file. I have sent you a data file called dataset EFA. So it has 18 variables. So what happened is that this is a small data which has been collected from some, we are trying to understand the service quality of some tertiary care hospitals. Around 80 respondents were there. We have given our responses on these 18 attributes, which are these attributes x1 to x18, and they are reviewed a 7-point Likert scale to give their attributes to their responses. Sorry. These are the variables. I will go to the data file. Yeah. This is the data file. So I'll straight go to running of the factor analysis. Once I run it, I will analyze. I will explain the other parts. You go to analyze, you go to dimension reduction, and then you go to factor. Select x1 to x18. In the variables, go to descriptives, click on univariate, coefficients, significance, KMO, reproduced. Univariate descriptive initial solution, coefficient, significance levels, KMO, reproduced. These are the check boxes that you need to check under descriptives. Everybody has followed it. Once everybody is okay, then we will go to the next one. So stop me anytime, anywhere in between when you are having any difficulty or not able to follow anything. After you have done this, let us go to, we click on continue and go to extraction. The method is principal components that we are using and mostly used. We'll select on this, all the other things are already selected. Only thing is we need to select this tree plot. Now you can see in that extract there are two options. One is eigenvalue. The other option is fixing the number of factors. In some cases, you may want to have the factors to be fixed, means you want only 5 dimensions or 5 factors, or 6 or dimensions or 6 factors. So in those cases, you may sometimes fix the number of factors. And in that case, but in very rare cases, generally we don't do that, because mostly when you are talking of by EFA, by nature it is exploratory in nature. So if something is exploratory, you should not fix the number of factors. But sometimes in rare cases, if you are sure about the number of factors and you want to fix and get that number of factors only, you can use this option and give the number of factors that you want to fix. Otherwise, mostly we use this button only. And when you have done that, click on continue, go to rotation and go to Remax. Now, what is rotation? Rotation is necessary to make sure that the factors or groups that you are getting are independent of each other. They make it, so Remax rotation is the method that is known as orthogonal rotation, which is a 90-degree rotation. So when you are talking about 3-dimensional figure and every factor is at a 90-degree to each other, it is orthogonal in nature, which means it is independent of each other. And that's why this rotation method is needed. And you select the Remax as the rotation method and click on continue. There is option, something called as options. We will not use it at this moment. And there is something called as scores. There is the use of each of these, but we will tell you later why and where it is to be used. As of now, we are not using them, but they will be used later. So let us go to the next part. Click on OK. So we'll come to the output table. Let me go to the output. Yeah. So this is the output one. The first thing that we will look in a factor analysis is this table, KMO and Bartlett's test of sphericity. KMO is a measure of sample adequacy, as we have told, and we need the KMO value of factor analysis. Ideally, it should be above 0.6, but sometimes in some cases we use or we check for anything above 0.5. So acceptable value for KMO should be above 0.5. If it is not, then there is a problem in your data and you need to go back and check your data. And along with KMO, there is something else called as Bartlett's test of sphericity. It basically checks for the hypothesis that I mentioned in the slide, that correlation matrix is an identity matrix and is not significant, and alternatives correlation matrix is significant. So that test result is given in the Bartlett's test of sphericity. And in this case, can you tell me whether this test is significant or not, looking at the significance value? Can anybody tell me? Is this test significant? Look at the significance value. Yes?
Yes, the p value is less than, we can say that
Significant.
it's significant.
Yes, it is less than 0.05. In fact, it is less than 0.01 also, 0.000. So basically, this is significant. That means we are rejecting the null hypothesis. And that means the correlation matrix is significant and there are some factors which can be done. So once you have checked, this is the first thing that you need to check, the KMO and Bartlett's test of sphericity, and that is the first thing that you need to report also. That KMO value is above 0.5 or not, and Bartlett's test of sphericity is significant or not. If you report these two are okay, then you go forward and do the rest of the analysis. The next thing that you look at is this thing called as communalities. What is a communality? Communality is nothing but what is the percentage of that variable which is explained by all the factors that you have extracted. What percentage of the variance of that variable is explained by all the factors that is extracted. So let's say you have extracted or you have got 5 factors or 6 factors when you have done the factor analysis. How you have got 5 and 6, I will come to that. But let us take that you have expected 5 factors. So what percentage of the variance of that variable is explained by all the 5 factors together is explained by this value of communality, which is the value that we will look at is under extraction. So this value should be above 0.5. So 50% of the variance should at least be explained. That's why the value of communality which should be above 0.5. Now, looking at this, you can see then there is a small borderline case, which is X17, which is below 0.5. Rest all are above 0.5. Now, what to do here if your value falls below 0.5? So if it is a borderline case, we may not think of it much. But there can be certain situation where it is not borderline and it is quite below that 0.4, 0.3 or something like that. Now, if that happens, in that case, you need to drop the variable. And remember, factor analysis is a trial and error method. If needed, and most of the times, you will always see there are some variables which needs to be dropped, and which needs to be dropped should be dropped. You should not hesitate about dropping those variables. So, looking at this, since it is a borderline case, we are not thinking of dropping it. But in some cases, if the value is quite low of the communality, you should drop it. It should be dropped. Now, if that is the case, then let's take an example that there are 3 variables where the value is quite below 0.5. So when that is the case, how many of those variables should you drop? When that is the case, how many of the variables that we dropped? And in fact, there are 4 different methods in which you can drop the variable. This is only one method of that. I'll come to all the 4 methods. So let's say you have 3 variables which are quite below, which are the communality value is very, very low. Let's say in the range of 0.3, 0.4. So in that case, how many variables should you drop? Can anybody take a guess? Take a guess. Let's say 3 variables which are below 0.5, which needs to be dropped. How many should be dropped?
Sir, all the variables who are less than 0.5 if it's not a borderline case.
But they should be dropped together.
No, we can try maybe one by one.
Yes, that's exactly what you do. Never ever drop all of them together. Always look at the lowest value, drop it, and rerun the analysis. Remember, whenever you are dropping a variable from the factor analysis, the variables are changed, and so you need to rerun the analysis. So you should drop the lowest value one, remove it from the data, and rerun it again. And it may happen, dropping the lowest one may solve the problems for the other two. They are very there. Often it has been seen, you drop 1 or 2 one by one. After that, there were several variables which were showing problem, but are dropping 1 or 2 variables which were having the lowest value of commonality. The problem is solved, and all the others get their value goes up, and the threshold value of 0.5 is crossed. It may happen, and that is the exact reason you should not drop all of them together, but one by one, starting from the lowest one. Lowest one, remove, rerun the analysis. Check the commonalities again. If there is still a problem, lowest one again, remove, rerun. And in that way, you go on till you get all of them in the acceptable range of 0.5 or a borderline case of 0.5. That is the next thing that you need to look at and report. After that, you need to look at or decide, as I said, how many factors, number of factors. So how many factors should be there, or how many factors? We never say that we group the factors and all those. What we say that we have extracted the factors. We have extracted the factors. So how many factors are extracted from these 18 variables? There are 2-3 different ways of checking for it. One is this total variance explained table. If we look at this table, you will see there are 6 factors which are having an eigenvalue more than 1. So as per this table, there are 6 factors that have been extracted from these 18 variables. This is one. Then this is another scree plot. Now this shows whenever there is a very sharp drop after or a kink after a certain point, that is the number of factors that you get. Now this becomes a slight problematic when you have a very large number of variables. If you have 6, 7, 7, 8 variables, it becomes easy to interpret. But with 18 variables or more variables, it sometimes becomes difficult to interpret. Here in this case also, it's not very clear which is exactly the number of factors, because after 2 it has come down basically. The third method, how many factors have been extracted? Look at this matrix, rotated component matrix. How many components it is showing? It is showing 6 components. And that means you have got 6 factors, or 6 factors have been extracted from the 18 variables. Or so you have grouped the 18 variables into 6 different groups or factors. Fine, but always look at the rotated component matrix, not the normal component matrix. There are 2 matrices you will get. One is this component, one is rotated. And rotated gives you orthogonal factors, or factors which are independent of each other. Okay. Now, when you are doing this, let us come to the factors. Now, we have to decide that 18 variables are grouped into 6 factors. Now, you have to decide which variable is under which factor. That you have to decide. And for that, you need to look at this table. And these values that you are seeing are known as factor loading values, which is nothing but the correlation between the factor and the variable. So for x1, which is the highest value? Can anybody tell me?
The 0.642 is the third factor.
Yes. So under which component or factor it is showing?
Under third.
Third. That means the variable should be under third factor. Similarly, go to x2 and you can see the highest value is under factor 4. Don't look at the negative and positive sign. It look at the absolute values only. So highest value is 0.548 and that means it should come under factor 4. Now in this way, for each of the 18 variables, you need to look at and decide which variable comes under which factor or grouped under which factor, looking at these loading values. Now that becomes a problem because if you have a large number of variables, now in this case, you have 6 factors, you have 18 variables, 18 into 608 combinations, and you have to see upwise, downwise, everywhere. That becomes a real problem. Now, what to do to solve this problem? You have to solve this problem. Correct? So, that's why we use the option that we have not used before. There is something called as options. You can suppress the small coefficients. And let us take this value of 0.4. Now, what will happen if you are doing this? Now come to the rotated component matrix table. See what has happened? It has removed the smaller values which are below 0.4. That means that they are not removed completely, they are hidden basically. You are hiding those values so that it's easy for you to understand which variable will be under which factor. So looking at this, can you tell me under factor 1, which will be the variables? Which are the variables which should be under factor 1?
10,
10,
17, 18, 13,
10, 13,
16 and 18.
16 and 18. 10, 13, 16 and 18 should be under factor 1. Similarly, under factor 2, it will be 3, 5, 9 will be under factor 2. Under factor 3, 1, 6 and 7. Under factor 4, 2, 8 and 12. Under 5, you have 4 and 15. And under 6, you have 11, 14 and 17. Clear? Which variable under which factor? Any doubt till now?
Excuse me, sir.
Yeah, tell me.
Sir, in this table, suppose in component 1, there are 5 values. Sir, all the values are to be considered
No.
like.
See, X17, where is the highest value? It is under 6, na? Which is higher, 401 or 429?
Oh, yes, sir. Row wise, we have to check.
Yes.
Also. Yes, sir.
That's what you have to check.
Yes, sir.
So that's why 17 should not be considered under factor 1. Only 10, 13, 16 and 18.
Yes, sir. Thank you, sir.
Yeah. So in that way, you have to check. So because the other values are not removed, they are only hidden. Anything below 0.4 is hidden.
Sir,
Yes.
what if two values are almost equal?
Yes, I'm coming to that. Correct. There comes a second and third method of dropping variables. The first method was communality. The second and third method comes here. So there are two issues here. One is known as cross-loading, another known as low loading. Both can be the reason for dropping the variables from this factor analysis and rerun the analysis whenever you drop the variable. So if you look at this, our first case is what you said correctly, what is known as cross-loading. Like in this case, 401 and 429 is very close to each other. Very, very close to each other, the values are. So if that is the case, this is known as a cross-loading problem. The two highest values of loadings for a variable is almost similar to each other for the two different factors. And this is a problem of cross-loading. Whenever you have a cross-loading problem, you need to drop that variable and rerun the analysis. That is one case. What is the second case? Low loading. Now, what is low loading? Low loading is something which you need to look at as something called as whether the highest value of the loading is itself enough or not. The highest value, like in this case, 401 and 429. 429 is the highest value for, and that's why the variable is put under factor 6. Now, whether this value is itself high enough to be acceptable. Now, what is acceptable? That the question comes. Now, acceptability comes or depends on the loading value's acceptability, whether it is a low loading or not, depends on the sample size. Now, what is that? So, if you have a very small sample size, let's say 50, 60, the minimum value of loading which is to be acceptable is around 0.7. If you have a sample size of, say, let's say 8500 around, you need a minimum acceptable loading value is 0.6. Similarly, you go up to 120, 130, 40 around, minimum value is 0.45. Around 150 to 200, 0.4, 250, 0.35. 350.3. So as the sample size increases, the minimum acceptable value of the factor loading also goes down. So in that way, if you look at this in that way, so if your loading value is low, the highest loading value that you are getting, based on which you are deciding that this factor is coming under this variable, that itself is low, then you will consider it to be a case of low loading, and that's why you will remove that variable. Both in the case of cross loading and low loading, which should be checked separately, you need to remove the variable, and each time you remove a variable, you need to rerun the analysis. And similarly, just like in the case of communality, if you have more than one variable showing this problem, you never ever drop them together. You always drop the lowest one, rerun the analysis, recheck. It may happen dropping the lowest one will solve the problems for other variables, and you may not need to drop any other variable. And in this way, you go on doing till you get an acceptable value. So these are the three methods based on which you drop the variables whenever there is a need. One is communality value, second is low loading, third is cross loading. All these three methods has to be checked. And it is often necessary that you drop the variables, because factor analysis is a trial and error method. You start with a large number of variables and you may need to drop them if there is need, and if any of the three criteria it is failing. So if you look at this, you can see X17 had a problem in case of communality also, though it was a borderline case. That's why we have not looked at that, or we have ignored it at that point of time. But coming to this here again, you have a communality problem. You can see 0.49. It was a borderline case. Coming to this rotated component matrix, this is showing a problem again. 401, 429, two very close value, a problem, a classic case of cross loading. So in that case, it is better because out of the three criteria, it's already falling into criteria. And if you look at the loading values, sample size is 80 in this case. An acceptable loading value is somewhere around 0.45. So in that low loading also, it is having a problem. So now let us rerun this analysis by removing this X17. And this is needed in many of the cases. The famous example of SHIRSHENDU that I said. SHIRSHENDU is a scale, has 22 dimensions or variables and 5 factors. Originally, this started with 110 variables and came down to 22. Now we rerun the analysis using the, after removing X17. Click on OK. See, the KMO value has also improved, and in fact, it was 0.641, now it is 0.655. Looking at the communalities, everything is done. Everything is above 0.5, no problem here. In this also, this variance explained also, it is showing again 6 factors only. And rotated component matrix is also showing 6 factors only. And this looks a better proposition now. Now, in this way, you need to rerun it if you have more than one problem or more than one variable showing this problem of either cross loading or low loading or several other things. So till this, is it okay or anything is there? Any doubt?
So why some variables have negative sign?
It may happen that the way the question has been asked is slightly in a negative worded. And that's why people have given that response. And that's why negative. It may happen. We don't know the exact wordings of the questions in which it has been asked. Okay?
Okay, sir.
So whenever you have a negatively worded question, this may happen. The solution for that is whenever you have a negatively worded question, reverse code it. So this was a 1 to 7 Likert scale. So in case of those variables which are negatively worded, you reverse code it. 1 becomes 7, 2 becomes 6, and in that way. Instead of the normal coding, you reverse code the variable when you are coding the variable in your data file. That can solve the problem of this negative coefficients coming. Because if this negative coefficient comes, sometimes if the highest value itself is negative, because when you are looking at the loading and deciding which variable is under which factor, you do not look at the negative positive sign, you look at the absolute value. But there may be a problem which can come later. Not here, but in the later, there is something called as reliability check and Cronbach's alpha, which will look at it. There the problem may come. It's not that it will come, but it may come sometimes. If these negative loadings are there and your highest loading value is itself negative in nature. Till now, everything clear? Any doubt here? So what do? We start with looking at the KMO and Bartlett's test of sphericity. KMO value should be about 0.5. Bartlett's test of sphericity should be significant. After that, we look at the communality values. They should be about 0.5. If not, and if it is quite low, you may need to drop the variable. If there are more than one variable, always drop the lowest and always drop one by one. Don't drop all of them together. Then look at the factors, decide on the number of factors, which can be decided from the number of eigenvalues which are above 1, which is 6 in this case, or in the scree plot, which sometimes become confusing. The third method is looking at the rotated components in this. It is showing directly which variable under which factor. And in this case, it is 6 factors from 18 variables. But one variable was showing a problem of low communality, though borderline case, but it was showing a very severe problem of low loading and cross loading. And that's why that variable was removed, X17, and we did that. Basically, we rerun the analysis. Whenever you remove a variable, you rerun the analysis. And whenever you remove a variable, you always remove only one variable at a time, not all of them together. Whether you are using it because of communality, because of low loading, or because of cross loading. Now, this eigenvalue table, again, I'm coming. Now, what is this showing? As I said, communality is showing what? Each of these communality values, if you look at the communality values, let's say first one. What is the explanation? 66% of the variables of this variable x1 is explained by all the 6 factors together. You have got 6 factors, or you have extracted 6 factors. So 6 factors together explain 66% of the variables of this variable x1. Similarly, 73.5% of the variance of the variable x2 is explained by all the 6 factors together. This is the, so communality is the percentage of the variables of the variable which is explained by all the 6 values together, factors together. And exactly opposite is this eigenvalue. This shows what percentage of the variance of the factor is explained by all the variables. So if you look at the variance 22.492, always don't look at this 22, always look at the rotated one. 15.378, 13.415, 11.521, 9.503. This shows what percentage of the variance of the factor is explained by the variables. Exactly opposite. So what percentage of the variance of the variable is explained by all the 6 factors together is your communality value. The variable, and in the eigenvalue, if you see these values 15.37, it is showing that heading itself is percentage of variables. What percentage of the variables of that factor is explained by all the variables. So that is what it is showing. So you need to always report what is the total variance explained. So 6 factors together explain what is the total variance. So here, in this case, the 6 factors that you have got or extracted together explain 66.61% of the variables. Or 66.61% of the variance is explained by all the 6 factors together. That's exactly what you do. Clear? Or not?
Sir, in TVE, how much is the ideal value, or we can say it's acceptable?
There is no ideal value as such.
Okay.
There is no ideal value, but generally, I have not seen anything below 50% coming. I have never seen anything below total variance explained. When you are talking of all the factors together, I have never seen below 50%. So you can say then there is no ideal value, but you can say 50% should be at least there. So if all of them together do not explain at least 50% of the variables, the data is not very stable or not a very good one. You can say in that way. Okay.
Yes.
Yeah. Now there is another table which will help you to understand how good is your factor analysis. And that is this table called as reproduced correlation. So it shows there is a correlation matrix table at the start. You can see this. This basically based on this or on the basis of this, which variables are highly correlated among themselves, the factors are made. Now, after the factors are made, they recalculate the calculation, and that's why it is called reproduce correlation. And they will check the original correlation with the reproduced correlation, and the difference is in this residual column. Now, this should be below 0.05. The residuals is basically the difference between the reproduced correlation and the original correlation. Their absolute values of this residual should be below 0.05. Now, if these absolute values, in this case, you can see there are 63 values. That is 46% of them are having absolute values greater than 0.05. Now, this value shows the stability of your factor analysis and how good is the factor model. It should be always below 50%. The number of non-redundant residuals or the number of residuals above 0.05 should be below 50%. As long as it is below 50%, you are okay. You are safe with it. So this should be another thing which should be looked at and reported and checked. Clear? Here it is 46%, which is below 50%, which is good. Okay, acceptable. Not good. I am not say good, but it's acceptable. Clear? Now, there are some cross-checking which can be done with your communality and with your eigenvalues, which is often done and often very, very common thing to be done. Now, what is that cross-checking? Looking at this rotated matrix or your component matrix, whatever you can look at, you can back calculate the values of communality and eigenvalue. One second. Yes. Now, these loading values that you see, if you square and add them for each variable, so if you square and add them from left to right, that is 0.013 square plus 0.227 square plus 0.642 square plus 0.441 square plus 0.054 square plus 0.096 square. That is from left to right for that variable. If you square and add all the factor loading values, that will give you the communality value. So this will give you the value of 0.67. And similarly, with the value of 0.718, you will get, if you square and add this 0.302 square to 0.217 square. So if you add all the factor loadings for that variable, after squaring them, it will give you the communality values. And similarly, instead of going from left to right, if you go from top to bottom, that is 0.013 square to up to 0.776 square. For all the variables, if you square and add the factor loading values for each factor, that will give you the value of this eigenvalue, 3.976. This is a cross check or thing which you can back calculate your eigenvalues and your community values using the factor loading table or the rotated component matrix table. So if you square and add from left to right, that is for all the factors under a variable, you will get the community value. If you square and add from top to bottom, that is from your factor loading values for all the variables under each factor, it will give you the eigenvalue, the value of the eigenvalue. Now, if you see this value of this variables that you have got, this is the variance explained for each of the factors. This can be calculated from the eigenvalue. So now this 3.976 into 100 divided by number of variables gives you the value of 22.088. Hundred into 3.976 divided by 18 is 22.088. Similarly, 100 into 2.127 divided by 18 is 11.815. So multiply the eigenvalue with 100 and divide it by the number of variables will give you the variance explained this value. Any doubt here till now? Anything on this back calculation, or what is commonality, or what is eigenvalue, and all those? Any doubt? If there is no doubt, we'll go forward. That's why I'm asking. Any doubt? Yes. Eigenvalue is that variance explained, that is basically the percentage of the variance explained by a factor explained by the variable, all the variables. Communality is the percentage of variance which is explained of a factor which is of a variable which is explained by all the factors together. Now, percentage of the variance of the factor explained by all the variables together is your eigenvalue. That percentage of variance. Eigenvalue does not have any significance. The percentage of variance is basically what you are concerned about. Clear? Now, once you have done that, and we have looked at all these things, reported all these things, comes the next part. So till now, what you have done is data summarization, which will end up with naming the factors or labeling the factors. Now, how will you name or how will you label the factors? So looking at all the variables which are there under each factor, we name or label the factors. Now let us go to the last one. Now, what is the naming done, or how is the naming done? The first factor is having x10, x13, x16, and x18. And what are the variables? Timing convenience, individual attention, customized treatment, and patient listening. Timing convenience, individual attention, customized treatment, patient listening. Looking at these variables, I have named or labeled this factor as empathy. Remember, we are finding out the dimensions of service quality for these hospitals. Second factor has having X3, X5 and X9, which are accurate billing, knowledgeable employees, and feel safe. So this factor has been named or labeled as reliability. Third factor, X1, X6, X7. Physical facilities, up-to-date equipment, employee appearance, tangibles is the name or label given. Fourth factor, brand name, service variability, and availability of information. So I have named it as image or reputation. Fifth, helpful employees and promises kept. Assurance is the label given. And the last one is having these two factors, that is 11 and 14, 17 as we have removed. So we have prompt service and quick and efficient diagnosis. So we have named it as responsiveness. Empathy, reliability, tangibles, image, assurance, responsiveness. So all the 6 factors is named on level, and if you do not do that, it is not complete. The completion of factor analysis is only possible if you are leveling it or naming it. So again, I am saying this is known as the data summarization. That is reducing the data into less number of variables, which ends with naming the factors. Now, the second part that we talked about is data reduction. Now, once we have grouped them into 6 factors, the original variables, before coming to that, any confusion on that naming or any doubt on the naming or labeling of the factor? Anything?
Sir, excuse me, sir.
Yeah, tell me.
Sir, the naming or labeling should be done intuitively and then put somewhere, or how it is to be represented?
Not intuitively, looking at the variables which is coming under that factor.
Yes, sir.
What are the variables which are coming under the factor? For example, the first one was timing convenience, individual attention, customized treatment, and patient listening.
Yes, sir.
So we have named these as empathy. Or the last
Yes,
one,
sir.
prompt service, quick and efficient diagnosis.
Responsiveness. Yes, sir.
So in that way, look at the variables which are coming under that factor or which are grouped under that factor. And looking at the variables, you should name the factors. The name or label should be something which should cover all the variables under that factor.
Yes, sir. Yes, sir.
Okay.
Yes, sir. Thank you, sir. So are we going to represent it, how are you going to type it, or where to show it actually? What is the representation?
How to represent it, now? How to
Yes,
report
sir.
the result?
Yes, sir. Yes, sir.
We'll show you.
Yes, sir. Okay, sir. Thank you, sir.
Yeah. Now, after naming, which is data summarization, which is complete, there is the data reduction part, as I said. That is, the original variables do not exist anymore once you have grouped them into factors. Now, these 6 factors that you have got is your variables, which can be used in several other analysis or multivariate analysis. It can be used as independent variables in regression or discriminant or cluster or several other multivariate analysis. So original variables were represented by those numbers now, which were there in the data set. Now this do not have any representation or how to represent it. If you have to use it further for other analysis or other techniques, you need to represent it with some numbers. And that is the data reduction part, which can be done by 2 methods. One is the factor score method. One is the mean score or summated scale method. And how it is done? When you run the analysis, do you need to put operational definition of factors or describe them in terms of variables? Now, in terms of variables, you need to. So if you are giving that variables, in terms of the variables, you can always look at that, and as per the variables, you can name them, and that itself will give you an operational definition. Sometimes you need to give an operational definition also. Yeah. So now data reduction part. One method is the factor score method. Now what is that, or how is that can be done? It can be done directly from this SPSS itself. Go to analyze, damage reduction and factor. There is one more method thing which we have not used, which is this scores. So if you look at this and click on this save as variables, just click on the save and variables, nothing else. Continue and OK. Analysis will be what you have run similarly. But if you go to the data file, go back to the data file, you can see something are being added. This is the data reduction part. The factors, the 6 factors that you have got are the new variables that you have now. And to represent the new variables, we got this known as Carter scores, which is the weighted average score of the factors. Of all the variables, you are doing a weighted average of the variables. And what you are going is a factor scores. You are getting low values and all those like this because it is a normalized score. This is one method. Let us talk of the second method of data reduction or representing the factors as variables. Now for the second method, we use the summated scale or mean score method. So what are the 4 variables which had grouped under factor 1, 10, 13, 16 and 18? Look at these values. For each respondent, if you look at these values, 10, 13, 16, 18. 2 plus 1, 3 plus 1, 4 plus 1, 5. 5 divided by 4, 1.25 is your mean score or summated scale method. Similarly, for the second person, 2 plus 3, 5 plus 4, 9 plus 3, 12 divided by 4, which becomes 3. So for each factor, you look at the variables which are there in the factor, look at the values in the data set for those variables, add them and divide it by the number of factors, and that is known as the mean score method. So you can use factor score as well as mean score. Now what happens is sometimes when you use a factor score, which is a normalized value, it may become a mismatch of scale. Let's say you are using this x1, x2, x3, x4, the new factors that you have got as an independent variables in a regression analysis. So your y is not factor analyzed and it is still in a scale of 1 to 7. But all these x's that you are using, the factors that you are using are factor scores. They are all normalized in nature. In some of the cases, it may give you wrong results, or it may give you too good or too bad results. Too bad is also bad, too good is also bad. In that case, you do not use the factor score, you come back and use the mean score method. So basically, whenever you are using or taking the results of factor analysis forward for use in other multivariate analysis technique like regression, discriminant, etc., you always need to check for factor score as well as mean score, which gives a much better and interpretable results. You need to use them. That only. Clear? Clear or not? Factor score and mean score method, both of them. Is it clear or not? Any doubt?
Excuse me, sir.
Yes.
So in the mean score method, we are calculating and we found out, suppose 1.25 and 3 by dividing the number of factors.
Yes.
So how will we determine what is to be determined there actually?
Nothing is. It is not to determine. It is representing that variable. Original variables are not there. Now these variables are these factors.
Yes, sir.
To represent, like original variables are represented by these numbers, not 2, 3,
Numbers.
2, 1, 4.
Yes, sir. Yes, sir.
So now when you are getting the factors, these original variables do not exist anymore.
Yes,
now
sir.
your variables are these 6 factors. To represent those factors, you need to use the factor
method.
scores or mean scores.
Mean
One
scores.
of them.
Yes, sir. Yes, sir.
So now these are the new 6 variables which will be used or which can be used in other multivariate analysis technique, like in a regression, you can use them as independent variables, or you can use as independent variables in discriminant, or you can use them in doing cluster analysis or whatever. Now,
Yes, sir.
that can be represented by either factor score or mean score. So what happens is that sometimes factor scores may not give good results because along with these variables, which is the factors, the other variables are used which are not factor analyzed. They will be in a scale of 1 to 7 or 1 to 5. This will be not. So in that cases, it may give sometimes it may give bad results or sometimes 2 good results. Both is possible.
Yes, sir.
So in this scenario, you need to use the mean scores. So basically, whenever you are using the factors, when you are getting the factors and then using them in getting the in other multivariate analysis techniques, you should always check for using mean score as well as factor score, which gives you a much better and interpretable results. You need to report that or use that. Clear?
Yes, sir. Thank you, sir.
Yeah. So that is the data reduction part of the factor analysis. Now comes the last part. So any factor analysis or EFA or exploratory factor analysis has to be checked for reliability. Now, how do you do that? That is done by a method called as convex alpha, which measures the internal consistency. Or what do you mean by that? What are the variables which are coming under this factor? How consistently they are intercorrelated among themselves. So to do that, you need to run the analysis again, and I'll go to the. Now we have got this. First factor has 10, 13, 16, and 18. So for the first factor, we'll run that convex alpha analysis. So you go to analyze, go to scale, and go to reliability analysis. Analyze, scale, reliability analysis. So that's what you need to go to. What are the 4 factors? Variables under factor 1, 10, 13, 16, 13. These are the 4 variables which are under factor 1, 10, 13, 16, 18. So put them into items, go to statistics, on these variables, scale, item, scale if item related, and correlations. Nothing else is needed. These 4. Continue. Okay. Now this shows a convex alpha value. So looking at this value called as convex alpha, you have to see how reliable is the factor. or how internally consistent in the factor. In that sense, what we mean is these 4 variables are under this factor, how closely they are correlated among themselves and making a coherent, closely knit factor. That is measured by this convex alpha value, which is being shown as 0.733. Always look at the standardized item, that value, not the normal convex alpha value, standardized item. So 0.733 is the value. This value should be ideally above 0.6, but above 0.5 is also accepted. Now, somebody asked a question. If there is a problem or if there is a negative coefficient in the loading value, which is highest value, in that case, not always, sometimes it may become a problem in this convex alpha value. This value will give you some junk values in some cases, not always, because the question may have been interpreted wrongly or something like that. So in that case, you may get a junk value in this. But here the value is quite good, 0.733. And that means you are quite, because it is not only above 0.5, it is only above 0.6 also. And that's why it is a good value that you have got. So this convex alpha value is quite good, acceptable. The reliability of the factor is good. Now here comes the 4th criteria. As I said, sometimes you need to drop variables. When you need to drop variables, what is the basis? First basis is communality. Second, low loading. Third, cross loading. 5th is this convex alpha criteria. And how is this criteria used? You are basically talking of just one second. Yeah. Look at this convex alpha if item deleted. This value. In item total statistics, you will see the convex alpha if item deleted. Now, is any of this value below 0.733? None of them are below 0.733. All of them are below the value of 0.733. That means everything is okay. If it is not, or any of the values is above that convex alpha value, what is this value showing? This is showing that if you are removing the variable, what will be the convex alpha value? So in that scenario, it may happen that variable has to be removed. If it is not, fine, but sometimes you may need to remove the variable based on that convex alpha. When the convex alpha if item deleted value is well above the value of the actual convex alpha, it may be needed to be removed. This is the 4th criteria of removal. Now, how will you? I will give you the other one. If you remove the second variable, which was no, this one, 6 and 7, I think. This will show a problem like that. I'll show you the value running the analysis. Yeah. If you run the value for that same one, 1, 6 and 7, the value is 0.92592. Okay, still okay. But look at this convex alpha if item deleted for x1. This is having a value more than that. That means what we are saying, if you are removing the variable x1, your convex alpha value for this factor goes up by 2.605. So if that is the criteria, you need to remove that variable. If this happens, and rerun the analysis again and repeat the procedure. That's what it is looking at, or that's how you do the factor analysis, the reliability check, which is using convex alpha. Now you can see there is something called as corrected item total correlation. Now if this is high or more than the convex alpha value, convex alpha if item deleted, this item total correlation also will come very low compared to the others. And then this, you are sure that this variable has to be removed. And again, if you are removing the variable, you need to rerun the analysis. Whenever you remove a variable, whether due to communality, whether due to low loading, whether due to cross loading, or whether due to this convex alpha item deleted, in all the 4 cases, you need to rerun the factor analysis whenever you remove a variable. So that is your reliability or convex alpha value that you need to remove. Now only convex alpha is not enough for checking the reliability, because convex alpha cannot be used for factors which have only 2 items under it. For example, factor 5 has only 2 items under it. One is x4 and another is x15. Since 2 items are under that, for that you cannot use convex alpha for reliability analysis. For those type of factors, you need to use correlation coefficient. So for 4 and 15, if you have to report the reliability, you need to use this correlate bivariate and check these variables and click on OK. So if this correlation is significant, that means the factor is reliable. So in this case, the correlation is negative, but it is significant, 0.018. So the factor is reliable. So in case of factors, you can get a factor with only 1 variable also. In that case, nothing is needed because only 1 variable is there. But in case a factor has only 2 variables under it, you need to check the correlation coefficient among the 2 variables as a reliability measure. For the others, you use convex alpha as a reliability measure. And convex alpha is the 4th criteria based on which you may need to drop the items. So convex alpha has to be checked, and we have to check. First of all, convex alpha should be above the value of 0.5 at least. Ideally, it should be above 0.6. And second, you looking at convex alpha value and looking at convex alpha if item deleted. If the convex alpha if item deleted value is high or higher than the convex alpha value, that means it is showing if you remove the variable, that is convex alpha value is going up or reliability is going up, and that means you need to remove the variable and rerun the analysis again. Clear till now or not? Any doubt?
Sir, we can't use EFA when we have derived, or maybe we can say when we have taken factors from a literature review. Like, for example, I have taken perceived usefulness, perceived ease of use, which I have taken from previous theory.
TAM model, you are saying technology adoption model.
Yeah, TAM model, or maybe some factors I have added new also. So in that case.
No, when you are directly taking the factors from the literature review and not changing anything, then you can directly go to the CFA, which we will be doing in the second half of this FDP. But if you are adding some new variables or new items, or you are trying to mix and match some 2 variables or 2 constructs from 2 different scales, or you are changing the context in some way, in that case, you should not go directly to CFA. You should use first EFA and then go to CFA.
Sir, I have not mixed the variables of two factors, but I have taken variables from two or maybe three different research papers because
Ah,
I wanted five statements at least, maybe.
then you should go for an EFA first and then go to CFA.
Okay.
Because you have taken for two different sources, na? The scales
Yeah.
are not same.
Mm-hmm. Okay.
That means also a mix, basically.
Okay.
So that's why you need to do that. EFA first and then CFA. Okay.
Okay.
Yeah. So the next thing comes is how to report this result. Yeah. Yeah. This is a paper I have written. I'll show you how to report the results. Yeah. So you have to look at tell me about the commonality and total variance explained and all those and everything. You have to just tell them. And then we have given some sort of names to those factors using the variables. This is the way of reporting. This is the factor name, the items or variables under that factor, the highest loading values, and the convex alpha value. And if you look at this last factor, because it is only two variables under it, I have used correlation coefficient instead of convex alpha value. Anything which is having at least three variables under that factor will be using convex alpha. For anything which is having two, you need to use correlation coefficient. This is exactly the way you report it. The factor name, the variables under that factor, the loading values, and the convex alpha value. This is how you report it. Any doubts? Yes, name of the article. Okay. So clear how to report the results of factor analysis or EFA basically. CFA will come in the next step. Next we'll go to CFA, where you confirm the factors. So any doubts till now? If there are not, then we'll take a break. If you get any doubt in between also in the break, you can come back and ask me that whatever doubts you are there. And after the break, we'll do the CFA part, the confirmatory factor analysis. So I'll take a break of around 10-15 minutes and then come back and do the CFA part. If you have any doubts, you can gather your thoughts. Just think of what I have discussed, and you get any doubts, you can ask me after the break. Okay.
Hello, sir. I want to know one thing.
Yeah, tell me.
Sir, please kindly provide me the link for SPSS and all this. I did not have.
I don't have a link at this side because we have a licensed version I'm using.
Okay.
Institute. But there are a number of you can say versions available. Your crack versions available of both SPS and Ramos. You have number of crack versions available. You can go to this what is this called? Start for you and all those you will get.
What, sir?
Start for you.
Okay. Thank you.
There you will get number of crack versions of both SPSS and Ramos. Number of versions are there.
Okay.
You can get there.
Okay. Thank you.
Yeah, I am using a licensed version, so I don't have this crack version.
Okay.
I have a crack version in my home laptop. There I have. You can get it from chat for you. So
Yeah.
we'll take a break. Yeah, tell me.
This meeting is being recorded.
Sir, actually, I read it in an article or maybe somewhere, like we don't do EFA and CFA on the same set of data.
Ideally, they should not be. But
So
sometimes you don't have a choice because you don't get enough data. Then you have to.
Actually, I'm in the pilot study stage. I'm a research scholar. So I have collected the data of around like 80 to 100 respondents. And because I have merged the statements from 2 to 3 sources for one factor, you have recommended me to do EFA and then CFA.
Yes. But how many variables you have?
Variables, like I have 13 factors, which I have like gathered from LR, and like including independent and dependent factors. And for each
EFA has to be done for all of them, na? That's why I'm saying.
Yeah. And for each factor, I have 5 statements or maybe 5 variables.
So around 25.
No. It's like total statements or variables would be 65.
65, okay.
Yeah.
And then 65, when you have 80 or 200 will not be enough to run any analysis.
Okay. So how
you need at least 400 plus.
Okay.
And anyhow, pilot study, you don't run any analysis. Pilot study is mainly for taking that language, etc. and all those things.
Okay. So in pilot study, I should like do what all I should test.
You should just basically look at the language, structure, questioning and all those, and everyone is trying to write on all those. So basically it is making your questionnaire more robust.
Okay.
But you have to run EFA analysis. 65 into 10 is ideal, but ideal you cannot get at least 65 into 5, which is 325. But to be safe side, I am saying 400 plus you need to run EFA. CFA is also a large sample size. You need around 400, 500 for that also.
Okay. Thank you so much.
Yeah. Stop here. And so till now we have discussed EFA. Any doubt or anything that have come in between when you are taking a break? If not, we will go to the CFA straight. Okay. Now CFA or conformative factor analysis is the second part of after EFA. It's also a factor analysis, but it is also a part of what is called as SEM or structural equation modeling. But we are not going to discuss structural equation modeling here. We are talking of only the measurement model or CFA part of structural equation modeling. How to run it and how to report and what to report. That's what exactly we will be talking of. We are not going into theoretical parts of what is SEM and structural equation modeling and etc. So the CFA is also known as the measurement model, which is one of the 2 parts of the SEM or structural equation modeling. Now, when you're talking of CFA, it is showing how good your construct is. So whatever you are going to get as constructs or factors in EFA, you do it or you try to confirm it using CFA. Now, when you are doing that, sometimes it may happen that your literature review, you directly take the constructs or factors form, and there is no change. You just are trying to do it for your purpose. So in that scenario, you may not go for EFA, you can directly go for CFA. But for that, you need a very strong theoretical support, which is very, very important part. Without that, you cannot directly go for CFA. Unless, on most of the cases, what you do is go for in EFA, and then to confirm the factors that you have got from EFA, you go to CFA. Now, what is the difference between EFA and CFA? EFA basically is by name exploratory in nature. It explores the data for patterns and reduces large number of variables into smaller number of variables. And only after you get the factors, you can name the factors, because at the end result, you get the factors. While in case of CFA, you already start with the factors being made. These are the variables under these factors. And what you do is you test or confirm whether the factors are good or not, and how good is the model with all the factors that you are talking of. Diagrammatically, you can see this is basically the difference. A factor analysis or EFA, you will see each factor, each variable loads under each factor. In case of CFA, only a particular variable will load under each factor. So there are certain other things called as model fit indices and reliability and all those. We'll come back to those things after I run the analysis and all those. We are not going to look at this at this moment. First, we'll talk about how to run a CFA. So I have given you a data file in which there are 6 variables and number of 6 constructs or factors and number of variables. So the data file have those 6, you can see, constructs, which are CS, CL, ER, IS, SC, and S. What are those constructs are given here, and how many variables are there in the data file is also given. So one of them has 4, another has 3, another has 4, 2 or 3 of them has 6 variables under each of those factors. The data file that I've sent and the description of the data file is also there. Now, what you do is, first, in a CFA, you need to draw a diagram in Amos. And how do you draw a diagram? So we have 4, 3, 4, 6, 6, 6. So this is the Amos screen. And how do you draw a diagram here? Let's say you have a construct which has 6 variables under it. One of the construct was that is SC, staff confidence. Now, how do you draw the diagram? You will go to this particular thing, draw a variable, this one, draw the construct like this, and then number of variables that is under that factor, you just click on that circle that many number of times. So if you have another variable which is of having 4 factors under it, you again draw it, and now you can see this becomes very congested one. So in that case, what you do is you select these ones and then you rotate it so that you can arrange and put all of them in a neat manner. So that we don't waste time on this diagram thing, I have already drawn the diagram for you. So I'll show you the diagram with all the 6 factors and constructs. Yeah, this is the diagram. So three of them have 6 variables under it. 2 of them has 4. 1 of them has 3.
Sir, which software is this?
This is Amos.
Amos.
Yeah. So in the same manner, I have drawn the diagrams. And after you draw the diagrams, there is one more thing is needed, which is this covariances among the constructs. So among these 6, there will be internal covariances, which you can do by this button, one by one, but it becomes sometimes cumbersome. So what you do is select all these 6 factors and use the plugin to draw covariance. It will draw the covariances for all of them together. If you select the 6 factors, let us remove them and I will draw it again. If you remove them, you select these 6 factors or constructs, use the plugin and draw covariances. It will be drawn. Covariances are drawn. To run the CFA, you need to draw these covariances. After that, you can load the data file. For running the analysis, you need to load the data file. To load the data file, you need to select these options, select data file. You go to this. Here it is there, already selected. If it is not there, you go to file name and select this data file and click on open. It will come. How will you know this selected? This N290 out of 290, this will show you. If it is not selected, this 290 will remain blank. So once you select the data file, click on OK. So your data file is selected on which you will run the analysis. Now you have to name this. This is already named. To name it, what to do? You can have this list of variables in the data set once you load the data file and just drag and drop them on this thing and to naming the constructs as well as the variables under it. Or other way, if you want to do it manually, you can right out it, go to object properties and put the variable name directly here. Similarly here, also object properties and put the variable name directly here. And for each variable, you can see there is an error variance which is to be given. This also can be named from the object properties. Or it can be also named through the plugins. You can name the parameters through plugins also. So this is what is the diagram. So we'll confirm these factors. So we have already done an EFA and found these are the 6 factors which are coming. As I said, I have given you the data set, the description also. These factors are customer satisfaction, customer loyalty, technology usage readiness and reliability, technology security and information quality, staff competence and customer service. So this is a data where we are trying to find out the hybrid service quality model for a banking system. So these are some of the constructs. This is not the actual data. This is not the actual, the full data. This is a part of some of my research, which I have done from PhD. So it is only some of the constructs I have taken for illustration purpose. It has more number of constructs under it. But these are the 6 constructs or 6 factors I have taken, and this diagram has to be drawn, and then all these constructs, etc., has to be named. So once you have named them, you have loaded the data file and everything. you need to go to this analysis properties and look at output and click on these boxes. Minimization history, standardized estimates, squared multiple correlation, modification indices, indirect direct total effects, covariances, correlations, and test for normality and outliers. These are the things which you need to look at. Check boxes. On the left hand side, 1, 2, 3, and last one. And on the right hand side, 1, 3, 4, and 6. And then click on, no need to click on OK or anything, that is nothing called, just close it. So once you have done that, the next thing that you need to do is running the analysis. How do you run the analysis? This button, calculate estimates. Click on that. It will show it is going to run. How will you run? The run has been successful. You will see this. This will come. And this running thing which happened, which was going on, it will show. And once this running analysis happened, this text button, which was disabled till now, which is the output button, will become enabled. And from there, you can see the output. You can see the output. Are you able to see the screen? Let's share it one second. This is the output. Everyone can see it now?
Yes, sir.
Yes. So the output, one of the first thing that you need to check is whether the factor loadings are significant or not. And what do you check it? You check it under these estimates. So this is a model which is having 6 constructs or 6 factors, and under it there were total 666,434. That means 29 variables. 6 3 18 and 443, that is 11. Not sorry, 27 variables. No, sorry, 448 plus 8. Yeah, 29 variables, correct. Now 29 variables is there. The data size also you can see 290. So it is granting that criteria of 10 into 29 to 90. And also AMOS is something where you need a large sample. It is very difficult to run AMOS or CFA with a smaller sample. You need a very large sample. Some 200, 300, 400, depending on the number of variables. This is important. And another thing has to be very, very clear in case of CFA. The average number of variables under the construct should be 3 or more. That means here you have 6 constructs and you have 29 variables. So how much is 29 divided by 6? It is almost 5. This should be at least 3 or more. That is very, very important. So if somebody is having only 1, 2 or 3 variables, that is not okay. On average, you should have at least 3 or more variables in each construct. So in this case, we have 6 constructs and 29 variables. So that is not a problem. So we have these conditions before we run this thing. So once you have run this gives you, we need to look at the results. And what do you look at the results? The first thing that you need to look at is this. This is the significance of the factor loadings. Here you check the significance of the factor loadings. So if you see the significance of the factor loadings, the p-value is showing you the significance of the value loading. Wherever you are showing star, that means it is 0.00 or less. It is 0.00 or less. Okay. That means all of them are significant. So you can see this, each of these path that you are showing from the construct to the variable, it is it can be treated like a regression path. Now, whether it is significant, you are checking. Now you are seeing that for each construct, one variable, the p-value is not showing because the estimate is 1. Like in CS4, 1 is there and you cannot see the p-value. That is because if you go to the diagram, you can see that for each variable, one path has been fixed as 1. For each construct, it is happening. One of the variables, it is fixed as 1. For that value, the significance is not calculated. Why? Because what happens, this is an iterative procedure. To start the iteration procedure, you need to change that. You need to fix one of the paths as 1 and then run the iteration to calculate the significance of all the others. Now to check whether this one is also okay or not. So what do you need to do? You need to go to that particular object and then remove the regression weight from that and put the regression weight into another one which was not there and rerun the analysis. See, when we are running the analysis, again the text output has become invisible. So even once you are run the analysis, the text output will come. So let us go to the text output again. So in this case, you can see CS4 now has been checked. CS3, we have removed 1 and changed from CS4 to CS3, and that's why the CS4. So for all the ones where the significance is not coming, you can just move that one to another one and check for the significance for that particular construct and variable relationship. So in this way, you can see all the 29 variables, and for all of them, it is significant. So these are something like the factor loading values. We also call them as regression weights, because as we said, each of these paths is something like a simple regression. Now the loading values that we generally look at is not the normal ones, but it is the standardized loading values that we look at, and which is shown in this table, standardized regression weight. This is the standardized regression weight table. So your factor loading values, when you report these results, just like an EFA, you need to report the factor name, then the variable, and then the loading values. So in this case, the loading values are given in this table, which is known as standardized regression weights, which are these values. So this is the loading value that you will be reporting when you report the results of CFA. Till now, any problem?
So do we need to report the above table also?
Which one? This one?
Yes.
No, only the p-value. How will you report? I will show you.
Okay. And we can like put one regression weight on any, like in the first analysis.
Which one?
You put one other regression weight.
Because what is happening, for one of the variables for each construct, one is fixed as 1. For that p-value is not calculated. To check for that, you just move it to another one, which is already checked for, and you rerun the analysis. So for all the ones which are there, for each construct, there will be one path which will be fixed as 1. So for all of the 6, you need to remove that one and move it to another one within that construct and check for those 6 which were not checked because they were fixed at 1. Just like I have done for CS, for all the other also, you need to do it for every.
Okay, and what if p-value is not significant? If it's coming not significant?
If p-value is not significant, you generally need to remove it.
Remove
Variable
that
to be removed.
Yeah, okay.
Excuse me,
But
sir.
very rarely it will come like this, because mostly what you do is you do an EFA and then come for a CFA. So whatever removal problem is happened now already is done and cleaned in the EFA level. So very rarely you will find a non-significant CFA in this case. Okay.
Sir, excuse me, sir.
Yeah, tell me.
Sir, if you are changing in the construct the 1.00
Not changing, just
estimate,
moving it to another one.
yes, I'm moving it. So is there something the best out of the 4? Which one will be the best?
No,
one?
nothing like that.
Nothing like that. Yes.
Nothing like that. There is no best or all those things.
Yes, sir. Yes. Thank you, sir.
All 4 are significantly loading under that construct. That's what you are checking.
Yes, sir. Thank you, sir.
If this construct has 6 variables under it, all 6 should be significantly loading under it. Nothing else. And the loading values are the standardized regression weight, which you need to report. So you need to report the factor label, factor name, the constructs under it, the loading values, which is the standardized regression weight, and the p-value. In this case, the extra thing that you need to report is the p-value. And there are 2 more things that you need to report, which are known as AV and CR. I'll show you first how to report it, and then I will explain it. The result is to be reported like this. The same paper that I have shown you. It is like this. See, measurement item. Here I have given the constructs. You do not repeat the factor name basically. The standardized estimate is the standardized regression weight, or that we have shown in the Amos output. The p-value is there. And instead of in EFA, what did we report? We reported Cronbach's alpha. So instead of Cronbach's alpha, there are 2 more things here, which are known as AV and CR, which has to be reported in this case. And besides this, there are some other things which will come to you one by one. But let's look at what is this AV and CR. And these are like what was Cronbach's alpha for EFA, CFA is having these 2 extra things. So this is how you report the results. Now, what is AV and CR? Yes, it is the same article. It has been done, EFA was done, and then after that CFA was done. Yeah. Now, what is this CR? It is called as composite reliability. So it is showing how overall reliable is your factor or the construct. The value is between 0 to 1, and generally the value ranges about B.6, 0.7 is considered to be good. This is the CR. So higher the value, better is the composite reliability. Then there is something called as AV. This is the value of AV. It is something like that various explained that we have talked about in EFA. It is somewhat comparable to it. Now there is a formula for calculating both CR and AV. The formula for CR is square of the sum of loadings for that factor. That is in the numerator, and in the denominator you have the same thing, square of the sum of loadings plus error variance. Now, what is that? The formula, I will explain. I will go to the output and show you how to calculate it. This is something which you need to calculate. You cannot. It will not come automatically. For that, I need to go to the output table. Now, CR value is, as I said, square of sum of loadings. That means, what are the loading values for, let's say, take CS? The loading values are 0.895, 896, 840, 913. So, add of this is one of the terms is square of sum of loadings. So, let us open a calculator. Can you see both the calculator and the screen? Can you see it?
Yes, sir.
So one value is for CS, you have to calculate error. One is square of sum of loadings. That is 0.895 plus 0.896 plus 0.84 plus 0.913. So you multiply it by the same value, that is square of this value is 3.544. So remember this value 12.56. The other thing that we need to look at for this CR value is something called as error variance. Now, what are the errors which are there under CS? The error numbers as per the diagram are E1, E2, E3 and E4. So go to this value called as variances and look at the values of the error variances. That is E1, E2, E3 and E4. So add those error variances to this 12.56 plus 0.345 plus 0.228 plus 0.288 plus 0.193. So this is coming to 13.61. So your square of sum of loadings divided by square of sum of loading plus error variances. That is the previous value that we got, 12.56 divided by 13.61 will give you the CR value for this particular construct or factor, that is CS. So in this way, you need to calculate the CR values or composite reliability values for each of the constructs and report it in that table. Is this clear?
Yes, sir.
Okay. Then how to calculate this AVE? AVE is slightly different formula. Instead of square of sum of loadings, you add the sum of squared loadings. So in the case of CR, you have added them and made the square of the sum. Instead of that, if you have to calculate AVE, you have to square them, that is 0.895 square plus 0.896 square plus 0.840 square plus 0.913 square. This you need to do, and the formula is same, that square divided by square of that plus error variance. Now, for this, you do not calculate the square directly. It is already calculated in this table. The square of this loading values is already calculated in this table. This shows the square values of this. So if you are talking of this square of these four values, 0.895 and 968.0, this is already there in this squared multiple correlation table, which is this values CS1, CS2, CS3, and CS4. So it is already calculated here. This is known as SMC or squared multiple correlation. This also has a purpose. I will tell you what. But let us calculate the AVE first. In this case, it will be 0.834 plus 0.706 plus 0.804 plus 0.8. This is the numerator. Denominator will be this plus the error variances, which are again 0.345 plus 0.228 plus 0.288 plus 0.193. So the formula for AVE is the first value that we got, that is sum of squared loadings or SMC, sum of the SMC values divided by sum of SMC values plus error variances, this value. So 3.144 divided by 4.198 will give you the AVE value, which is 0.74. So your CR value for this construct CS has come as 0.92, well above the acceptable limit of 0.6, 0.7. And for the AVE value, it has come to 0.74 or 0.75, you can say, rounding it off, which is well above the acceptable value of 0.5. So in this way, you need to calculate the AVE and CR values of both the construct. Now, you are calculated composite reliability, CR value, and AVE value. Now, what is the use of these things? So there are certain things called as validity checks, which are reliability or validity check, you can say in that way, which is there as to be reported in case of your what you call as in the report. If you look at the same paper, I have reported some construct validity, something like this, reliability and construct validity and all those. So reliability is just the CR value and AVE values, which is there in this table. But there is something called as construct validity, which has to be checked. Now, how do you calculate the construct validity? Construct validity has 2-3 parts. One of the part is this called as indicator reliability, which is nothing but the SMC values. Now, what are these SMC values? I've shown you those SMC values, no? Which is the squared loading, squared value of the loadings. So that SMC value is nothing else, but you can compare to it with the communality value of EFA. It is the same thing as communality values. So for all of them, it should be above 0.5. So all your SMC values should be above 0.5. There are certain problems in this case, so we may need to remove them and recheck them, but it should be above 0.5. This is one part. Then the construct validity or the validity is divided into 2 parts. One is known as convergent validity, another is known as discriminant validity. Now, convergent validity is what? Whether the items which are or the variables which are under one construct or one factor, are they closely related to each other. How closely they are related to each other. So that is measured by two things. One is the factor loading values, which you need to report in those tables. That is the standardized regression weight values. So for all of them, it should be above 0.5. Another is the AVE value, which should be also above 0.5. If both these criteria are met, you can say my convergent validity is met, or we have achieved convergent validity.
So here factor loadings is equals to estimates.
Standardized regression weight. These values. Estimate in the standardized regression weight table. Clear? That is known as convergent validity. Now, convergent validity is not enough to ensure construct validity in this case. There is something called as discriminant validity. It shows the items or variables under one factor, how different it is from the items or variable under another factor, and how it is to be calculated. It is calculated by using two things. It is showing whether the AVE value for each of the construct is more than the squared inter-construct correlations. So you can see there are some inter-construct correlation in this output. Between the construct factors, there is a correlation. So your AVE for CS should be more than all these square values of this correlation of CS with all the other 5 variables. And similarly for each of them. Or the other way is square root of AVE is more than this value. Both ways you can check.
So can
Is
you
it
please
clear?
explain the method?
Either the AVE value should be more than the square value of these correlation values, or square root of AVE should be more than this particular correlation value. So if you have to check the discriminant validity of CS, you take the AVE value and check whether the AVE value is more than the squared values of 0.926 square, 0.457 square, 0.527 square, 0.611 square, and 0.547 square. So your AVE value should be more than the squared values of inter-construct correlations. So similarly for CL also you will need to do that for each of them. And the other formula is, instead of calculating the square of the correlation and comparing it with AVE, you square root AVE and calculate it with this directly with this correlation values. That is whatever square V value is have got for CS, square root of that value of that AVE, and check whether this AVE value that you have got, check whether square root of that is more than 0.926, 0.457, 0.527, 0.611, and 0.547. If they are, then your discriminant validity is established. So both convergent and discriminant validity has to be looked at and reported. Discriminant validity and convergent validity, as well as indicator reliability, has to be reported. Now, there are certain other things which are known as model fit indices, because whenever you are talking of CFA, yeah, what is the question? It is to be done for each construct. You have to do it, Soumitra. For each construct, you need to take the IAV value, and either you directly compare it with the with the correlation square of the correlation values, of that construct with all the others, or you take the square root of AV and compare it directly with the correlation value of that construct with all the other constructs. So for each construct, you need to do it. Clear? Soumitra? Now, there is something which is known as model fit indices, because what is talking of in CFA, this is a model. This is a multivariate model. We call it measurement model, as we said initially also. This is called as measurement model. So when you're talking of this model, you need to report certain model fit indices, as I have done it in this paper also, you can see. Model fit I have reported. And what are those model fit indices? Generally you report, these are the model fit indices that you report. Now, where will you get these model fit indices? You will get these model fit indices in this table called as model fit. This is the chi-square by degrees of freedom value. This is the GFI, AGFI, PGFI value. This is NFI, RFI, IFI, TLFI, CFI values, which I am showing. CFI, TLI, GFI, AGI. And these RMR and RMSCA value are this. This is the RMR value and this is the RMSCA value. Now, how will you do, how these are called as goodness of fit or bad measures. This model fit are how goodly the model is fitting that data. How good is your model fitting the data? That's what you need to check. Or these are called as goodness of fit indices. G, all of them. Now, if you talk of this GFI, AGFI, NFI, RFI, IFI, TLI, CFI, all these values, except RMR, RMSCA and chi-square, these two and these values, which you are showing in this, the ideal threshold of all these values is above 0.9. That should be the value. It should be better.
So can you please tell for which 0.9 is there?
None of them are 0.9 except IFI.
No, like for what all values there, it should be 0.9 or maybe above.
GFI, NFI, RFI, IFI, TLI, CFI, PGFI. The value that is needed is 0.9. Ideally, it should be 0.9. Only GFI, AGFI is slightly less is accepted because it is an adjusted value from the GFI. So there you need to check for the value should be around 0.85 and above. But in this case, you can see only IFI and CFI is above. And TLI is almost close to 0.9. For the others, it is quite low. Now, there is a way to improve it. But before doing that, I will look at the other three things. Because I have talked about GFI, AGFI, and then there are three more things. This, and this. Now, all of these are basically GFI, AGFI, CFI. These can be sent as goodness of fit measure. So higher the value, better, 0.9 and above. The value is always between 0 to 1. 0.9 and above is good. Now for the three things, C mean degrees of freedom or the chi-square by degrees of freedom, RMR and RMSCA, it is exactly opposite. They are badness of fit measures. So basically lower the value, it is better. For chi-square by degrees of freedom, it is acceptable value is less than 3 or 4, ideally less than 2. For RMR and RMSCA, the acceptable value is less than 0.1, but if it is somewhere around 0.2 0.05, 0.06. It's good, you can say, but very good. But acceptable is still there. So in this case, RMR is within the acceptable level limit, 0.09, but not very good. RMACI is also within acceptable level limit, 0.085, not very good. But I-square by degrees of freedom is also around till 4 and below is acceptable. Not very good, but okay, acceptable. But in case of GFI and some of them, it is quite below 0.78, and we need to have 0.9 and above. Now, these model fit indices can be improved. Your model reliability or this goodness of fit indices can be improved. So, and the improvement method is known as modification indices, which is there in the output. There you can see the modification indices. So, these are the modification indices. You need to look at these values. Now, if you using these values, you can improve those model fit indices. So you can say it, this is a illegally legal way or legally illegal way of doing it. I think Mr. Umakant has given the feedback link. So you can give the feedback link. Feedback in that feedback link. Yes, share the feedback link. Yeah. So what is this modification indices? These values which are very high, if you are trying to do a covariances among them, then it will become, it will improve the model fit. So you can see a very high value between E22 and E23, 102. Then there is a high value between E1 and E5. E6 and E7. E8, E9. Only look between the errors. Don't look between the values between the error and a construct. E12, E13. E13, E19. E18, E19. E18, E23. Can take E19 and E22 and E20 and 28. Now looking at these values, we need to draw a covariance arrows, two-way arrows between these ones. So note it, I have noted it down. Let us go to the diagram and draw the covariance. The first one was between E22 and E23, which is here. Second one was E1, E5, which is E1 is here, E5 is here. Third one was E6, E7. Fourth one was E8, E9. Fifth one was E12, E13. Sixth one, E13, E19. Next one was E18, E19. Next one was E19, E22. E18, E23. And the last one was E20, E28. E20 and E28. Once you have drawn these arrows, you need to rerun the analysis. Once the analysis is run, you again go to the output and now check the model fit. You can see a marked improvement in most of them. Chi-square by degrees of freedom or C-mean by degrees of freedom has improved. GFI has improved from 786 to 0.849. VGFI also has improved. NFI, RFI, IFI, TLI, CFI, all of them has improved, and all of them have gone almost all above 0.9 except RFI. And RMR and RASCA. RMR has not improved much, but RMACA has improved, you can see. So most of them has improved. And you need to report last one. The last one, after you have used the model fit indices, the better one that you can report. The last ones, after you have used the model fit indices, you can report. And this model fit indices improvement is not a one-step process. You can again go back and to those modification indices and again check for some of the high values and try to relate them, and that will improve your model fit further. So till you get a very good, acceptable model fit, you can use these modification indices, and the final one that you get, you need to report that. Clear? Any doubt here? Any doubt? Yeah, in CFA. Anybody?
Sir, where is double NFI?
What?
Double NFI. I guess I saw that in the PPT.
It is there. I have to look at it. You are saying this one, huh? Oh. There are hundreds of things, so you have to look where it is. Now this portion is not having that value. It is a newly added one, so this version of Amos is not having that. It may come in the newer versions of Amos.
Okay. And do we also need to report RFI?
Whatever good values you get, you need to report. That's
Okay.
why so many values are there. Whatever you can choose and pick. Which ones you are getting good values, you can report, and which are not getting good values, that remove. But chi-square by degrees of freedom, GFI, and one of RMR and RASCA, and this one of this NFI, RFI, in that has to be reported. Chi-square by degrees of freedom has to be reported. One among the RMR and RMSMA has to be reported. Which one is better, you can report it. GFI, AGFI has to be reported, and around 2 has to be reported from NFI, RFI, IFI, TLI, this whole series. Okay. So if you look at my paper, this is I have reported the chi-square by degrees of freedom, CFI, TLI, IFI, NFI, PNFI, PCFI, and several others. So several others. You can see when you look at that output, you have hundreds of model fit indices. All these are model fit indices only. So many are there. So looking at that things, mainly these are the main ones which I have shown you, but there are several others which you can report and look at. So I've reported all these model fits. So when you are reporting the results of conformity analysis, the first thing that you report is this model fit. Once the model fit is there, and the model fit that you report is after you have used the modification indices and improved the model fit, that is the values that you need to report. And then you need to report the reliability, that is FE and CR values, as well as the indicator reliability, that is SMC values. And then the construct validity. Besides this table, of course, this is there already. And construct validity means the two parts, that is convergent validity and the discriminant validity, that you need to report. The CR, the indicator reliability, the convergent validity, AV, and discriminant validity. All has to be reported, as well as the model fit.
Sir, is it possible for you to share this presentation?
Yeah, I'll send you.
Yeah, thank you.
Yeah, so any doubt? Any doubt? Anybody? This workshop, actually, I have done a basic of EFA, and then I have just introduced you to CFA. There are two more workshops which are coming, which is exclusively on ACM. That is deal more into details of the measurement model. Which is on 14th October, the measurement models in details, as well as the structural model part of ACM. So basically, this is an ACM FDP, which will be coming on 14th October, followed by an advanced ACM option, which is a structural model mediation using ACM. These two workshops are coming, so that will complete the whole cycle of structural modeling. We have just introduced the basic of structural modeling, which is the CFA, in today's FDP session. So if you are interested in ACM, you can join those two more sessions, which are on 14th and 21st October on ACM. That will complete the whole cycle of ACM for you. And now, again, I'm asking any doubt, anything that you have currently, you can ask. It may happen that you may not get a doubt at this moment, but later on, when you look at this and revisit the things, you may get some doubts. You can contact me later also if you are having any doubts regarding this FDP. So those two FDPs that I have talked about are coming late. That will come. Only one is on 14th, another is 25th October. So after Durga Puja, it will come. So there is still time, but if you are really interested in ACM and you want to see learn the whole cycle of ACM, you can register for those two workshops, and that will complete your whole ACM part, structural equation modeling part. We have just introduced it with CFA in today's FDP. Yeah. So any questions, any doubts? I have sent a mail yesterday with the data files. Have you not got that mail? So in that is my mail ID. So you can use that. You can ask me anything, any doubt you have in that. Yesterday only I have sent that mail, where I have sent you the data files. I'll send another mail today where we'll have a refresher of these things, as well as I will send you these slides and etc. So in that, you can contact me in that email ID anytime you want to wish. Any doubt you have in future or anything. Yeah. So if you don't have any other doubts as of now for this FDP, we'll be closing the session. It will be shared. Mr. Umakant will share the recording. Neha. It will be shared. Maybe not today, but in next 2-3 days or somewhere, it will be shared. The recording will be sent to you. Okay, I'll send it in the mail. The research paper, na, I will send it, Sharon. Yeah. Anything else? Anybody else? Any other doubts? Any other questions? Shomitra, you are very silent. Mic not working. So you are coming for the next 2 workshop, ACM? The moderation and the normal ACM workshop, 14th and 21st October. Have you registered for that? Both of them. Okay. So I'll see you again there. Yeah. Yeah. So others who are interested in ACM can register for those 2. Okay. So we'll close. Time for lunch. People must be hungry. So you can go for lunch.
Thank you, sir.
Okay. So we'll see you. Some of you I will again see in the next 2 workshops, 14th and 21st. Shalom. Bye. So I'll close it now.